Let me introduce to you Michael Emerson, CTO, Extended Planning and Analysis at SAP. This rare experience, the person who is expert both in analytics and machine learning, artificial intelligence, and also finance as well. So Michael is based in Switzerland. He provided strategic guidance to multiple product development areas, such as business technology platform, FP&A, line of business finance. He was chief product strategist for product and innovation board office at SAP, contributing to formulation of SAP Intelligent Enterprise Strategy. He studied mathematics and computer science at the University of Edinburgh, MBA from Soda School of Business, UBC, attended leading product innovation executive programs at Harvard Business School.
Let's get going then. So I'm going to cover kind of a more holistic view of kind of what enables financial planning analysis, because everything starts and ends with finance, and I want to paint this complete picture to kind of show what is capable and kind of what elements are necessary for us to be able to deliver the kind of next generation of applications and assist our teams. As a basis, I always still like to start with this just to say, what is intelligence, right? It's that self-awareness, it's creativity, problem solving, and ability to learn and change our state, right, according to changes and situations. And sustainability as well. Sustainability is not just about environmental sustainability, but also sustainability is in maintaining something over time, like a business. And then planning, right? What do we do in advance? How do we do it? When do we do it? Who should do it? And how we bridge this kind of from what we're doing today to what we want to do in the future with kind of logical goals in a logical order. And with that, right, what is an intelligent approach, right? So when I think about analytics and planning, analytics is, what's happened, why it's happened, we report on it. As we move forwards after modeling, we kind of get into the planning phase where we're looking at what will happen and why will it happen to achieve an enterprise objective. And there's a lot that needs to go into that, right? In terms of which parts of the organization need to be involved, what data is relevant for the decisions I'm taking, what incentives need to be put in place to ensure that we're moving in the right direction towards this enterprise objective. But the problem today is that typically these enterprise objectives, think at the top level that are set by the board, they're obscured, right, with disconnected data, logic, and processes. Now, this is a very basic example, but essentially what happens is we then set, KPIs and targets across the business that might actually be conflicting. So in finance, might be looking at driving return on investment, a digital supply chain, trying to maximize throughput, managing inventory, human capital, trying to get the best people in, managing churn, etc. And what we often miss is when we're trying to deliver an enterprise objective, which is across these different areas, is kind of the cross impacts. And a lot of that time it's disconnected. So what are the steps towards an intelligent enterprise? Well, first of all, we want to connect our operational systems, right? Well, that's why we have ERP, right? Enterprise Resource Planning. The P stands for planning, because we're planning for our current, the objectives in the present, right? Our operational systems. The problem is we want to be able to project out into our enterprise objectives in the future. So what do? We build out plans along each line of business. And, but the problem is, while these are very good and they help us to work in the right direction, a lot of the time they're disconnected and we don't understand what the impact is of any kind of propagation of data across these different planning areas. So the first thing we need to do is connect this. Some people call it xP&A, some people call it connected planning, EPM. There are lots of different names for it, but the idea is having visibility across all the different planning areas, right? So you can have more of an agile approach. And the understanding is you want to accelerate the planning, execution, control, and prediction cycle, right, which can be very long, with this visibility of data, process, and logic at both the operational level and the planning level, which will help us be able to adapt or change, also be proactive to out-of-bound events that may happen. Another thing this does is we want to align our unconstrained plan, right? For example, our strategic plans, our sales plans, marketing plans, etc., to our constrained plan. So, what are our supplier agreements? How much do we have in inventory? And match that together and then loop that into execution. And it's very important that we have this cycle because we want to understand the cause and effect for any process, understand what decisions we're taking in the current day that will have impact in the future when we get there, so that we can then improve over time and optimize towards enterprise objectives that we've set, right? Might be in some cases 2 years, some cases could be 10, 20 years, depending on the industry we're working in. But there are certain technical requirements we need to be able to make this happen. And, some ask like, well, why have we not been able to deliver this in the past, sorry. And this has to do with technical limitations, organic development, and legacy processes. Oops, sorry, going too fast. Technical limitations could include, for example, the speed of databases, the networks we have, simple limitations around the amount of data we can process. Organic development, what I mean by that is, I showed earlier, we built applications that serve specific purposes in specific lines of business or domain areas that are still very good. But the problem is they lack the visibility into other areas of the business to be able to understand impacts of any decision that's been made. And then legacy processes, for example, those long planning cycles that are very inefficient, that don't necessarily have the right stakeholders involved maybe, and can't essentially adapt or change to anything that might come in last minute, right? So there's lots of different elements to why we've not been able to deliver connected plans in the past. And what we want to look for in kind of more globally in an end-to-end stack for end-to-end planning processes. Well, starting from the bottom, we want to be able to have that visibility at a data level. And that means having models that can align with each other. So be able to build advanced queries on top of multi-models. So aligning models from a demand supply point of view, aligning that with a finance point of view. And then on top of that, having logic that can be applied across these multi-models. And then again, on top of that, having processes that can run across these different planning areas where necessary. And also then from a UX point of view, having visibility of these processes that can be incorporated and include the right stakeholders from different areas of the business, so we can work towards the right decisions for an enterprise-wide point of view. And this, we don't want to, completely change, operational activities in a sense, because the idea is that everyone can become a planner. So when we say UX here, we want to be able to embed this type of information into operational applications that already exist today. And let me give just a really basic example. Imagine I'm working with a CRM tool and I'm talking with a customer, and a customer says to me, look, I want this product, could be imagine they're making trucks or something. I need 500 of these trucks at this price, at this location, by this time, can you deliver? And today that requires, quite a few people to work on it and be able to provide a response. You have to work out, do you have these trucks in inventory? If not, how much materials do I need to procure to be able to build that truck? Do I need to hire more people to be able to build this truck? Do I have the network in place to then be able to deliver it, etc.? And you think of all this information that needs to come together to answer this one question. And actually the data's there already in the system. And what we can do is actually provide, for example, in this embedded into a user experience should say, there's an 85% probability that we could deliver 500 trucks at this price, this location, right, at this time. But a lot of the time, we just don't have that visibility to be able to do it. And one example is, when we're aligning these different areas of the business, there are certain things we need to take into account. For example, aligning the different dimensions and measures that we have across these different systems. So, taking a financial perspective, just simply the time dimension, which is used everywhere, quarters don't necessarily line up to weeks, which might be a different area of the business, how they measure and how they plan. So we need to have the right types of allocation rules so we can handle queries, whether you're looking at it from a supply point of view, a finance point of view, an HXM point of view. Any area of the business should be able to have this view with regardless of how the data structures are underneath. And I'm going to get to how we line that. If we start then building on top of that and how we want to deliver kind of autonomous planning, right, on top of this stack. we start off with some of the traditional AI use cases, right? So if we're thinking using stochastic models, we've got things like predictive forecasting, where you can generate accurate forecasts on top of this data, including time series forecasting, and understand the impacts, for example, of any specific, it could be external variable like inflation rates or interest rates and other variables to take into account. We can then run simulations on top, understand which drivers within the business are having the greatest impact, and kind of build out kind of best, realistic, worst use cases. I mean, you can think of like Monte Carlo simulation on steroids, essentially. We can do demand sensing at a much more accurate level to optimize supply chains and inventory management, and then obviously doing segmentation as well. But these are just some examples, and all of these can actually feed into global optimization engines, which then optimize towards global objectives and not just within one specific area of the business. As we move on to generative AI use cases, we can actually build on top of this with kind of natural language querying, right? So, and this applies in the planning area. We can accelerate the production of visualizations with self-service analytics and self-service planning. We can generate much more accurate forecasting. We can actually accelerate the modeling process because we can actually generate new models automatically based on existing models that have been created, and drastically accelerate that whole process. We can also enhance and augment data models in place, and any kind of creation phase, whether it's creating planning or analytics interfaces or generating scripts for custom complex interactions, we can massively accelerate that. And in fact, we can embed it into all kind of key planning processes for FP&A and beyond, right? So, and because FP&A connects into everywhere, when you're thinking of these assistants, right? So many times, you might be asking impact on margin or trying to do an analysis quickly with some part of process that you're working on, and we can connect that into different natural language assistants that are working alongside operational applications. And it's not like generative AI is going to replace the value that traditional statistics and machine learning has provided up to now. It's a supplement, right? It's not like Gen AI is the right tool for all types of machine learning, right? So stochastic machine learning approaches still have their place and are very, very important, especially when we're looking at deterministic data and less of the more let's say ad hoc interactions that you might have with the system. And another thing I want to get into is I see that AI needs finance and planning just as much as finance and planning needs AI. And what do I mean by this? AI, right, is built on, we have foundational models, right, that we're building that are built on with text, image, speech, structured data that create these foundational models. And this is for generative AI. And what is interesting about this is that we don't need to rebuild models for for specific tasks, which we had to do with more of the classic machine learning approach. So it's almost like having an intelligent friend that you can ask a question. However, your intelligent friend might not necessarily know everything or know all the context, right? And this is where we have adaptation, where we can embed additional knowledge, use different fine-tuning techniques to then improve queries and provide additional information to our intelligent friend or these foundation models or these large language models, right? To then get more accurate responses for whatever process or for whatever response we need. And why finance is so important, right, is because everything starts with finance and ends with finance, right? So how do we bring this context into this loop, into this, this data, process, and logic? How do we get this all together to achieve these enterprise objectives? Now, I probably said it too early. I already said this. Everything starts and ends with finance. I've said it too many times now. But if we look at, just going back to the financial statements, right? Starting with our assets and liabilities, where we are at point A, and then how do we get to point B with our balance sheet, and understand what is happening to get from point A. So, for example, you go through different processes, such as, let's starting at the start, we might raise some capital Then we might, buy some PPE, hire people, manufacture a product, sell the product, collect receivables, all these different things that will, which will have postings on both the P&L and also on the balance sheet with different data structures involved. For example, with the general ledger and the material ledger, and loads of different databases that give us this overview of what is going on to then arrive at point B. And then we go through a process. We have the consolidation process. We have closing. We do, reporting processes. We have different data sources that are built upon it, such as the consolidated ledger. And then we move again. But the important thing is that we understand the cause and effect between what has happened in the current period so that we can better improve our processes and better predict in the future as we trying to move towards an enterprise objectives that we've set in the future. And that's very, very important to understand this cause and effect. And there are a couple of things we need to measure as we're doing this. So if we're looking at our current period, if we're looking at the process side, we want to capture what is happening within the process and the operational logic that's happening in the current period. And that could include, for example, performance benchmarks. Are we improving this process over time compared to the previous period? What's happening in terms of transactional execution? And what's that additional context in terms of notes that we can then align to the process data so that we can then optimize these processes moving forwards, right? Into our planning logic, right? So we can better predict based on processes that happened in the past, as well as the data that we have in the systems. Now, what is very important when we're trying to create accurate predictions of what will happen in the future is we need consistency in how we look at the data, right? So we need consistent data structures. And that means that what we have in our transactional systems has to align with whatever we have in our planning models. So we need the same, take a look at our chart of accounts, the financial statement versions, also the other master data that might be involved, such as like the suppliers we work with or the vendors we work with, and embed those into knowledge graphs, and where that provides flexibility and understanding across these different areas of the business, right? There are some industries that have a business partner could be a guard dog, right? I mean, there are some really interesting cases where you need some flexibility in these data structures, and a knowledge graph helps us provide that flexibility so we have consistency in querying from future periods to the current period, and as well as across different lines of business. And that way, right, we can kind of better simulate future outcomes, and we can be much more accurate, and we can be proactive and less reactive and build much more flexible systems based on the types of outcomes we can simulate. What we do is once we've collected all this data from the processes we've been working on, as well as the data that we have in our system from both our operational point of view and also the planning point of view, that can be represented, as I mentioned, in a knowledge graph. A knowledge graph is basically a way of representing data and the relationships between the different objects or data points that you have in your organization. That data can then be embedded into vectors. And the reason you want to do that, embed it into a vector, is to, as I said at the start, a large language model is like an intelligent friend that you can ask a question, but they might not know all the context. By embedding into a vector, and I know it says SAP here, it could be a different vector engine, doesn't have to be SAP, but I don't want to sell that, right? That you can actually then pass that information to a large language model and provide that better context to get a better answer. So you can avoid things like hallucinations, right? Hallucinations is where a large language model will come up with responses that it's just made up, the kind of the creative side of it. But obviously when we're doing accounting and we're doing finance, we can't have hallucinations. We need accurate responses to business queries. And when we provide this business context, we can actually eliminate these hallucinations to get much more accurate responses. And this whole process is called retrieval augmented generation. And again, it doesn't have to be with SAP, it can be with other technologies, but the whole overall process is the same. And the idea is that these patterns that you're passing inside a vector, right? So this is like just a very simple example of a two-dimensional vector graph. You're seeing, you can use it to cluster groups, right? And detect relationships between these objects for querying against larger models, right? And I don't want to get necessarily too deep into that, but it can, with these processes, right? And with leveraging large language model and the business context that you have, you can massively accelerate processes. This is just one example. For example, with a supply chain check, where you can actually eliminate a huge number of different checks that need to take place for a given process. This is just one example of a process, and thinking about all the different data points that need to be involved, but you can massively accelerate across in so many different areas. And the important thing is as we're looking into the future of how AI is being implemented, it's really important that we understand where it should be applied and how it should be applied in the right way, right? So it needs to be relevant, right, to your business processes. It needs to be reliable, which is probably the main area that I've been focusing on today in terms of making sure that we're getting the right types of responses in terms of the queries that we're sending to these large language models, and it needs to be responsible, right? We need to make sure that that data privacy is always maintained, and that we're not passing any old information without an understanding of where that how that data can be used and processed within a context of a large language model and generative AI. And to kind of finish it off a bit, as I mentioned earlier, extended planning is for everyone. And I see this, right, as a way as providing that visibility. So whether you're looking at it top down, right, from a corporate point of view, where you're trying to understand how can I allocate resources effectively, to the kind of the second layer of kind of connected planning would be that line of business steering, typically central controlling, where that interface between capital budgeting at the kind of corporate level, and then going down into lower down at the business, where they're having to understand, how to manage it at a KPI level for their specific area of the business. And then when we go further down into operational decision support, where we can actually help any individual. And like I gave an example of, using a CRM application where you'd get the probability of being able to deliver a product, where you can support any employee in any line of business by providing them information that's in your system that's aligned to your plan, where you can understand the impact of a decision that's made, not just in your area, but other areas of the business as well. And if we just take some examples in terms of corporate planning, you could be exploring the launch of a new product. It could be understanding the impact of tax and regulations. It could be competitive strategy, M&A simulation. There's so many different things you would be doing where this visibility across plan and connection to execution is so valuable. And of course, from a central line of business steering and central controlling point of view, being able to have that central finance, consolidated finance point of view with realistic product costing, capacity planning capabilities. The value is huge when you provide this level of visibility. And then, as I said, planning goes down to everyone. Whether you're working on a production floor and you want to understand what the impact would be of a material, right, on your production. If a particular material becomes unavailable and you're trying to build a car or whatever, you need to then manage that. And there are so many different people that are impacted by these out-of-bound events that are outside of their control, and then they want to have a system that helps them understand how best to respond and understand the impacts across the area. And when I look at some of the steps we can take, right, when we're trying to look at creating a connected planning landscape, I think it's really identifying firstly those primary use cases where connected plans really will provide a lot of value and get buy-in. And then obviously, trying to implement these types of use cases requires change management, helping colleagues adapt these new types of planning processes. Data is everything. You've got to prepare your data landscape. That doesn't change. Data is so important. Making sure you've got visibility, as I said, between planning models operational data, data structures is key. Making sure it's easy for business users to be able to model on top of this data, be able to align data from different models. And then we go through the enablement of the different planning levels, starting with level 2, because that's the connecting interface, and then supporting level 1, and then going through until level 3, and then adopting it across the board and accelerating planning cycles. And with that, I've gone pretty quickly through quite a lot of content because I know I only had half an hour to get through. But I would like to thank you very much, and I hope this was helpful, but I'm sure there are probably some questions. So with that, I will pause.